Okay, today we're going to look at our last lesson on logs and exponentials, and this is looking at some applications. So we're going to kind of be using logs and exponentials at the same time. All right, let's start with the first example. Here we have rabbits are introduced to a deserted island and the population grows in such a way that at time t months, now that's important, always pay attention to which units are being used in the question. So our t in our equation is in months. The size of the population n, so n is the population. This is very important to pay attention to because it'll become important when we have to answer questions, so you know whether you're trying to find n, t, or whatever. So the population at any time t months is given by this formula. 20 times 2 to the power of 0.1t. We'll start off easy. The first question we're asked is, what is the initial size? So initial, we need to think about what that word means. Initial always means in the beginning. So if we put it in the context of this question, in the beginning, that must mean time is 0. So t equals 0. So that's quite easy then. All we have to do is substitute t equals 0 into our formula, and maybe you can already see what the answer is if you remember your exponential work. So we'll have 20 times 2 to the power of 0.1 times 0. 0.1 times 0, of course, is 0. And then that means we have 20 times 2 to the power of 0. Then you need to remember anything to the power of 0 is 1, so 20 times 1 is just 20. So in the beginning, there were 20 rabbits. Put units if you know what the units are. Next question. How many rabbits will be on the island after 3 years? Now this is when it's very important to pay attention to this. In the question, it told us time is in months. So we can see here, now it's asking though about years. So we must convert them to the same unit. So we must make our years into months. So we just remember there are 12 months in a year. So we know that's the same as 36 months. Now once you do that, that's really easy. We can just then substitute into the equation. So it's wanting to know how many rabbits are there after 36 months. So n, remember, is our population. And we'll have then, given the formula, 20 times 2 to the power of 0.1 times 36. Now maybe you can work out that in your head. 0.1 times 36 should be 3.6. Let's just check. 0.1 times 36 is 3.6. So then we go across here. So it's 2 to the power of 3.6. Now, of course, you're not expected to work that out in your heads. And so we are going to use our calculators then. We can put it straight into our calculator. And so I can do 2 to the power of, I'm going to go answer. 2 to the power of answer times 20. Of course, you could have done 20 times. It doesn't matter which way you do it. Enter. And I get a big long decimal. So if I start by writing the decimal, so 242.51. 240, whoops, let's get our eraser. 242.51. I want. So equals, I can put equals because I'm 242.51 ... I don't need to write out the whole decimal. Now let's think about this, because the question is asking how many rabbits. We're talking about rabbits. So we can't have 242.5 rabbits. And we want in 36 months. So in 36 months, I would probably round that up. But I think it would also be acceptable to round down. If we stick to 3 significant figures, that's probably the easiest. I think it's acceptable to say 242 or 243. Maybe 243 is the most reasonable because there's 242 live rabbits at that point in time. But if you round to 3 significant figures, it would be 243. So as I said, either would be acceptable. So I'm going to say there were approximately 242. I'm not going to do the 3 significant figures this time. Rabbits. But of course, you can also say 243. So not so hard at this point. For C, we have to do a little bit more work though, because now the question's changed around. Now it's asking how many months. So if it's talking about how many months, now we're talking about T. T is the thing we don't know. So this is what we need to, that's the unknown. What we do know though is the population is 110 rabbits. So I know what the population is. And remember in our formula, N is the population. So now I can substitute N to be 110. And I can say 2 times 2 to the power of 0.1 times T. Right, there's a number of ways you can do this. You can do it algebraically, or we can do it, ultimately you will need your calculator, or you can go straight to your calculator. I'm going to show you 3 different ways that you could do this. I'll start with algebraically. So the first thing I'll do is I want to get T by itself. I'm going to get rid of this 2. So I'll divide both sides by 2. So I'll have 55 equals 2 to the power of 0.1 T. Now remember from our work with exponential and log equations, I need to take the log of both sides because I can't write 55 as 2 to the power of something. If I could, then it would be quite easy. So instead, we're going to take the log of both sides, just base 10. So log 55 is the same as log of 2 to the power of 0.1 T. Then remember we have the rule that we can bring the power down the front. And remember that whole thing, the 0.1 T, is all in the power, so all of it needs to come down. I might actually write this on the other side as well. So 0.1 T log 2 equals log 55. Then I want to make T the subject. I don't want the 0.1, I don't want the log 2. They are all being multiplied together. So I can take the 0.1 log 2 over by in one go. If I just divide both sides by 0.1 log 2, it gets rid of all of that mess. So I have log 5 over 0.1 log 2. Now I'm going to need to go to my calculator. So, calculator. We can just, let's get rid of this so it doesn't confuse us. Let's put it in as a fraction so we can put it in as we've written it. Remember that's alpha y equals enter. And then we're going to have log 55 on top. And then on the bottom we'll have 0.1 log 2. Enter. So we get 57.81 etc. etc. So 57.81 ... Now let's go back to the question. Key word again here is exceed. Exceed 110. So we said here it's exactly 110. So in 57.8 months it will be 110 rabbits. So normally when we talk about months we talk about whole months. So therefore it's going to take approximately 57.8 would be acceptable or greater than 57. I think it's acceptable to say it's approximately 58 months. So it will take approximately 58 months because T is in months. Approximately 58 months for there to be, remember exceed means more than. There'll be more than 110 rabbits. Okay, so that's one way to do it algebraically. Let's go straight to the calculator instead. We still need this first line, that's important. So you must have the first line there, regardless of which method you take. What we can do is we can get our calculator up, let's clear that. And we can just use the graph, we'll clear that. And we can just then put this function in, y equals 110. This function in, 2 times 2 to the power of 0.1 t, and we find their points of intersection because we want to know when they're equal. So I can put 110 in, and I can do 2 times 2 to the power of 0.1. Remember, we can just put x instead of t. Enter. Now what you might find when you graph it, oh, hopefully that doesn't happen. Let's just go to, I'll just quickly turn that off so we don't get that distracting us. Now let's draw it again. So you might not be able to see all of the graph. Particularly here, we can't see y equals 110. So probably my window's not big enough. So if I go to my window, I want my y to be able to at least show 110. So if I go to my y max, we can see it's 76.8. So I need that to be bigger. So what I might do is we'll do, say, 120. Probably want my y min. I'll just make it -1. Might change my y scale to, say, for example, 10, so it doesn't have so many little lines. Also, if I look, my x min, now I'm talking about rabbits and I'm talking about months, so I can't have negative months and I can't have negative number of rabbits. So I'm just going to make my x min -1. My x max, what will I do? I might make that, let's try 50, and we'll make the scale also 10. So look at the numbers you're dealing with to help you decide which numbers to use for your window. So I go to graph now. There's the line y equals 110. So I haven't gone far enough with my x-axis because I can't see the points of intersection. So let's go to window. I need more on the x-axis. So let's make that, let's say, 100. Hopefully that will help us. There's y equals 110. Excellent. So I can see both of them. So now I just go, I want to find their point of intersection. So I go second trace. I want intersect. So I just choose number 5. And then just follow the prompts. It's on one of the curves. It doesn't matter which one's the first curve. Jumps to the second curve. Yep. Have a guess. Now you don't actually have to have a guess. If you want, you can put the point reasonably close. Press enter. So you can see it's at 57.81, which matches what we got here. And of course, y equals 110. Now you might say, well, that's way easier than doing all this. What you need to do for your working out, you must have the first line of working, and you must draw a sketch of the graph. That's your working out in this case. So that's very important. So for this one, if I choose a different color, for if the graphing method, you must write that. And then if I just, hopefully you would have more room. You don't need all of the axes, so you can just draw the positive part. It's a sketch, remember? So you're going to have an exponential looking like this. And we had a straight line. Label your axes. So this is actually t for time. This is n for number of rabbits. This is 110. This is the y-intercept, so this is when t is 0, which we found over here, so I already know that's 20. So I'll write 20. This is the line y equals 110 to show what you put into the calculator, and this is then 2 times 2 to the power of 0.1 t. And then, of course, show the point of intersection. So you would show that point is 57.8, for example, 110. So that's your working out. This first line, your sketch of what's on the calculator, and then answer the question. So therefore, it would take approximately 58 months. I would round again. Whoops. Approximately 58 months. Now you only need to do one of these methods. You don't need to do both. It's just 2 different ways because, as I said, you have to use the calculator for both. However, be careful. Maybe sometimes it's on the non-calculator part and it asks for an exact answer. So then you must do this. You can't use the calculator. The other option is to use the calculator again, but this time, excuse me, let's get out of the graphing, and you could use the table. you don't have to have the 110 in there, but you do need this one. You can have it in there if you want. And we go to table. Table is above graph, so we go second graph. And these are the x values, which correspond to t in the equation. We want it to exceed 110. So you can see here are the number of rabbits after the various months. So obviously we've got to go quite a way down. And if you hadn't already found out the answer, you're going to have to find out when it's 110. Now you can make this a bit easier on yourself, is because it's increasing quite slowly here, you could try and, if you didn't know what the answer was, you could try and guess roughly where it might be. So for example, you could go to, maybe if you didn't know the answer, maybe say, oh, let's try 50. So you go, sorry, I didn't explain that. We go second, and then we go table set, which is above the window. That takes us here, and you can just tell it the table where to start. So it just jumps to a different place in the table. You can even change what it goes up by, but I wouldn't recommend that in this case because otherwise you might miss your answer. So if I say, for example, 50 and then enter, go back to my table, second graph, you can see it's jumped to 50. Now remember, the question is exceed, so it's more than 110 rabbits. So we can see here we've got 97 on our screen. So we would have to arrow down and then look at that. At 57, it's 103.97. So you certainly wouldn't round down in this case because it's less than 110. But after 58 months, we can see, not that it makes sense to have 111.43, but there would be 111 rabbits on this deserted island. Now, if you chose this method, what you must do, always write the first line down. That's very important. And then you would write, so if your answer is 58, you would write the 3 entries. So if I just move this a bit so we can see both screens, you're working out in this case, so I can see the calculator. If I choose a different color quickly, I'll choose blue. You're working out would still be the first line, and then if I can squeeze it in here, you'd have X, Y, or of course you can put T and N, and your answer is 58, so you write down the one above and the one below. 57, 58, 59, and then at 57 there were 103. This is just rounded. These numbers have been rounded, but that's okay. And then you've got 111.43, and then you've got 119.43. And then you can see, then you would again answer the question. So you'd write a little finishing statement. Therefore, it would take approximately 58 months. So if you do use the table method, as I said, must do the first line of working, must show part of the table, and then answer the question. Okay, hopefully that's some help, and we'll go on to another example in a moment.